Hello, everyone, and welcome to this virtual exhibition. Today, we're going to explore something pretty amazing, how we can take an everyday plant and transform it into some truly extraordinary technology. So let's just dive right in. I want to start with a question for you. When you picture a banana plant with those huge, lush green leaves, what do you see? A tropical staple, right? A source of fruit? Well, what if I told you it holds the secret to next-generation protective gear? Seriously, could it really stop a bomb? The answer, and this is the incredible part, is yes. The fiber inside the banana plant can be engineered into something unbelievably strong. And that, right there, is the heart of our story today. So, for this first part of our exhibit, let's talk about the why. I mean, conventional bomb blankets, they work, but they often rely on synthetic, non-biodegradable materials. This research is all about finding a sustainable alternative, tackling that environmental impact head-on. So the hero of our story is banana fiber. And get this, it's pulled from the stem of the plant after it's already produced its fruit. Now, this is a really big deal. It means we're taking something that would otherwise just be agricultural waste and turning it into a valuable raw material. And banana fiber isn't just eco-friendly. It's also naturally super strong and really lightweight. That combination makes it pretty much the perfect candidate for a green tech revolution in protective materials. Okay, let's move to the next wing of our exhibition. How in the world do you go from a plant stock to a piece of high-tech fabric? Well, this is where the real engineering begins. It all starts with this really meticulous, hands-on process. On the left, you can see these fibers being carefully extracted from the stem. Then, those raw fibers are woven together to create a structured mat, which you can see there on the right. This mat is our starting point, our base material. And it turns out, the way you weave it matters a lot. The researchers tested 3 patterns: plain, satin, and twill. The plain weave, too porous, too many holes. The satin weave was too slippery. The threads could just slide apart. But the twill weave, that was the sweet spot. It had the perfect combination of flexibility and strength. It was the clear winner, no question. But getting the right weave is just step 1. Now, let's head into what I'm calling the chemistry lab section of our tour. This is where that woven mat gets its superpowers, thanks to a very specific chemical recipe. The whole scientific process really boils down to these 4 steps. We've already covered the material prep. Now for the really cool part, the chemical treatment. Then making the actual specimen, which is just combining our treated fibers with other stuff to create a hybrid material called a composite. And then the ultimate performance test. Here's that second step in action. The woven mats get a quick bath in a mild 1% sulfuric acid solution. This actually cleans off impurities and roughs up the fiber surface a bit, which helps it bond much better with the other materials later on. And here it is, the magic ingredient, graphite. A little bit of graphite powder gets added to the epoxy resin that binds all the fibers together. The best way to think of it is like rebar and concrete. The graphite strengthens the entire composite, improves the bond between the fibers and the resin, and, this is crucial, it helps stop cracks from spreading. And if you want proof that the graphite really works, check out this chart. It's so clear. This shows how much water the material absorbs. The pink bars are the material without graphite, and the blue bars are with graphite. As you can see, adding graphite just dramatically cuts down on water absorption, which is absolutely vital for durability and performance. So we've got our material, banana fiber in a twill weave, treated with acid and reinforced with graphite. Now for the moment of truth. Let's move to the final stop on our tour, the blast test. And the big reveal? It worked. This quote from the research paper says everything. The composite remained structurally intact after the blast. I mean, that's the moment. That's when an idea from the lab proves it has real-world potential. And it didn't just survive. It performed beautifully. The damage was contained right at the point of impact. There was no catastrophic failure, no dangerous fragments flying everywhere. The blanket did exactly what it was designed to do. A success like this is just so exciting. But what does it mean for the future? In our final section, let's step back and look at the bigger picture and why this whole experiment is so important. So here are the key takeaways. First, this process turns agricultural waste into a life-saving product. It creates a sustainable, biodegradable alternative to plastics and synthetics. It enhances safety with a material that's both strong and lightweight. And maybe most importantly, it paves the way for a whole new class of high-performance materials that we can get right from nature. And that brings our exhibition to a close. But it leaves us with a pretty powerful question to think about. This journey, from a simple plant to a piece of protective technology, it shows what's possible. So if we can do this with bananas, what other massive challenges could we solve just by looking a little more closely at the genius of the natural world all around us?